Okay, it says find the mean, median, mode for the following data set. When necessary, round to the nearest hundredth. Anytime I see the word median in my problem, I'm going to rewrite my list in numerical order, smallest to largest. So looking here, the smallest number obviously is 83. The largest number is 89. You kind of want to get a feel for smallest to biggest when you're grouping it up like this. So, and it's on paper so I can strike out things as I write them. So 83, strike it out. 84, 84, 84, 84. Strike all four out. Don't see any more 84s. Next number up, 85, which is right there. There's only one of those. Next number, 86, isn't there. 87 is next. Got one of those. Looks like 188. And then there's 1, 2, 3 89s. If you just do a quick check here, verify that the same number of numbers is in both lists. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. That's going to be necessary to know as well, so there's no harm in doing it. 11 numbers, and if we count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So for the mean, I'm going to add everything up and divide by 11 because there's 11 numbers. So the mean equals something divided by 11, and the something is just the sum of all these numbers. I'm going to grab my calculator and punch it all in, see what I get. So 83 plus 84 plus 84 plus 84 plus 84 plus 85 plus 87 plus 88 plus 89 plus 89 plus 89 equals 946. And then 946 divided by 11 equals 86. Now that did come out to a whole number. It says when necessary round to the nearest hundredth. For mean, that's probably the one, or mean, median, mode, that's probably the one that will have to be rounded if necessary. This one came out nice and pretty, it doesn't have to. So again, nearest hundredth, 2 decimal places if necessary. If not, just write down the answer. So 86 is the mean. For median, we need the middle. So we need the same, for an odd set of data, there's one middle. And for 11, if you take away 1 from the odd number, that's 10, half of that is 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's how many numbers on either side of the middle number there be. So this is the middle number, so the median is 85. Quick check on median, just make sure that there's the same number of numbers as below and above that number. So 85 is the middle number that I'm claiming. There's 1, 2, 3, 4, 5 numbers left of it, 1, 2, 3, 4, 5 numbers right of it. Doesn't matter how big the numbers are, you're just looking for the same amount of numbers on either side. And finally for mode, mode is simply the most frequently occurring number in the list. And we can see here there are 4 84s, there's only 3 89s and 1 of everything else. So the most is 84. If more than one number happen the most, they would both be the mode. If every number happens once, there is no mode. So I don't think either one of those scenarios happens on this study guide, but I wouldn't feel bad about putting them on the actual test. So let's just pretend, what if there was another 89 here? Now 84 and 89 are both the mode. All right. And again, if every number happens once, nothing happens more than anything else, there is no mode. That's a possibility as well. For the particular problem I gave you, 86 is the mean, 85 is the median, 84 is the mode. Example 2, or problem 2. Find the mean, median, mode for the following data set. Same idea. These numbers have a little bit more variance to them. They're starting looks like 606 is the smallest. Looks like 756 is the biggest. And again, median's on the list, so I want to make sure that I list them in numerical order. So smallest number 606. Then 607, 635, 637, 658, 696, 727 twice. So 727, 727, 733, and finally 756. Again, quick check, count the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in our original list. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So all the numbers are listed, haven't forgotten any of them. For the mean, it's going to be something divided by 10, and the something is the sum of my list here. So 606 plus 607 plus 635 plus 637 plus 658 plus 696 plus 727 plus 727 plus 733 plus 756. Make sure all the numbers are typed correctly. They are, and we get 6,782. So if I do 6,782 divided by 10, I'm going to get an answer of a mean of 678.2. Again, it says in the problem, when necessary, round to the nearest hundredth. That's 2 decimal places, so we don't have to round, it's just that's the number. For median, for an even set of data, there's going to be 2 middle numbers. So if there's 2 middle numbers, I look at, minus 2 is equal to 8, half of 8 is 4. So 1, 2, 3, 4. 1, 2, 3, 4. These are my 2 middle numbers. And again, if you do a quick check, if those are my middle numbers, there should be the same number of numbers left and right of those. So there's 4 numbers left, 4 numbers right. These are the middle 2 numbers. When there are 2 middle numbers, remember there is the average of those numbers is necessary. So 658 plus 696 divided by 2. This is a careful, with your calculator, process. So I want to type in 658 plus 696 equals. I want to get the actual numerical sum on top, 1354 divided by 2. So then I would do 1354 divided by 2. I get a median of 677. This number should be in between these 2 numbers. The place where people mess up is if they type this in as it's written, 658 plus 696 divided by 2. 1,006, all it's doing is dividing the second number by 2 and then adding 658. This is not between those numbers. That should clue you into you probably did something wrong. But again, add them up, write it down, and then single number divided by 2 equals. That's how you want to do it to make sure you get the right answer. And finally for mode, I saw 2 727s as I was writing it down, one of everything else. So there's 2 of these, one of these, one of these, one of these, one of these, and so on, right? So 2 727s, the mode equals 727. Moving right along, number 3. Calculate the mean of the grouped data, round to the nearest hundredth if necessary. So, you've already got the frequencies, you have the class intervals here. The midpoint column is just the midpoint of each interval. So I want to average these numbers, and it's the same idea as we just did a moment ago with the median. I'm going to add 2 numbers and divide by 2. So, depending on your addition skill, I don't know, 0 plus 4.9, I think we can do it in our head, is 4.9 divided by 2 is equal to 2.45. So if you can add them in your head, you can get that single digit, that single number divided by 2. So this is 2.45. If I add 5.0 to 9.9, that's 14.9 divided by 2, which is 7.45. If the mental addition's not in your boat, you can always type it in. Like you can do 5 plus 9.9 equals, and then hit divided by 2. As long as you equal it out before you divide by 2, you'll be in the right boat. So 10 plus 14.9 is 24.9 divided by 2 is 12.45. Our class intervals are always in a pattern, so our midpoint should also be in a pattern. And you can notice here, everything's 0.45, 2 plus 5 is 7, 7 plus 5 is 12, so it just keeps on getting 5 bigger on the front number. So once I recognize this, 17.45 is 5 bigger, 22.45 is 5 bigger, 27.45 is 5 bigger, 32.45 is 5 bigger. You can always do the same technique all the way down if you want, but once you recognize a pattern, you can definitely use that pattern. That's how we fill in the midpoint column. And then we would fill in the product column by multiplying the frequency times the midpoint. It says right there FM, this is F, this is M, multiply. So 12 times 2.45 is 12 times 2.45 is 29.4. 9 times 7.45 is 67.05. 3 times 12.45 is 37.35. 2 times 17.45 is 34.9. 6 times 22.45 is 134.7. 8 times 27.45 is 219.6. And finally, 32.45 times 10 equals 324.5. To find the mean of grouped data, you want to find the total number of numbers, which is the sum of the frequencies. So we need a number right here. 12 plus 9, 21, 24, 26, 32, 40, 50. If you're not as comfortable adding in your head, you can always type that in a calculator. And then you want the sum of the products here. So you want this sum as well. The sum of these numbers represents the total sum. This is the total number of numbers, and that's what average is, sum divided by number of numbers. So this one's a little bit more challenging to add in my head, so I'm going to use the calculator. So 29.4 plus 67.05 plus 37.35 plus 34.9 plus 134.7 plus 219.6 plus 324.5. Quick check to make sure everything's typed in right. 29.4, 67.05, 37.35, 34.9, 134.7, 219.6, 324.5. All pluses in between. I didn't accidentally hit minus or times or something. Hit equals. 847.5 is the sum of all the numbers. Okay, so the mean of the group data is going to be 847.5, that goes on top, divided by 50, that goes on the bottom. 847.5 already in the calculator, divided by 50 comes out to 16.95. Again, it says round the nearest hundredth if necessary. That is the nearest hundredth, so everything's good about that answer. Number 4, same type of problem. The interval's a little bit less decimal, all right? But again, I'm going to add these together, divide by 2. So if I do that real quick, 22 and 26 is 48. So 48 divided by 2 is 24. 31 and 27 is 58. 58 divided by 2 is 58 divided by 2 is 29. 32 and 36 make 68. 68 divided by 2 is equal to 34. Again, I'm expecting a pattern here. 24 plus 5 is 29. 29 plus 5 is 34. 34 plus 5 is 39. 39 plus 5 is 44. 44 plus 5 is 49. Those are my midpoints. The products are just the frequency times the midpoint. So 4 times 24 equals 96. 7 times 29 is equal to 203. 11 times 34 is equal to 374. 39 times 9 is equal to 351. 44 times 5 is equal to 220. And 49 times 2 is equal to 98. So, my frequency is given, my midpoint's found by midpointing the class intervals. I multiply the frequency times midpoint to get my products. I want to add this column and this column to get the 2 numbers I need. So 4 plus 7 is 11, 22, 31, 36, 38 for the total number of numbers. I'll just do that one more time real quick just to verify. 7, 16, 27, 34, 38. Okay, coming on the other column, again, bigger numbers, harder to do in your head. So 96 plus 203, plus 374, plus 351, plus 220, plus 98. I was quick checking as I went along. Hit enter. 1342 is the sum of all those. So the mean of the group set of data, again, this is the top number, 1342. 1342 divided by that number, 38. So 1342 divided by 38 equals 35.31578,947. So once finally we got one that's not a nice pretty number. So you get a long decimal expansion. We want the nearest hundredth, which is the second decimal place. So if I'm rounding, 35.3, and then 15 means to take the one up one, so 32. So that's my mean. Number 5. Following table shows the average monthly precipitation in Seattle, Washington from March through August. Find the median monthly total for the 6-month period. So I see the word median, I know I need numerical order. So looking at the numbers, 0.79 is the smallest, 0.97, 1.63, 2.16, 2.77, and 3.51. There is an even amount of data here, so there's going to be 2 middle numbers. So 6 minus 2 is 4, half of 4 is 2. So I need 2 below, 2 above, and 2 in the middle. So my median is going to be the average of those 2 numbers. 1.63 plus 2.16 divided by 2. I'll finish this later.